So far, according to our attendance, there are 46. So we are still waiting for about 15 of you, but time cannot wait. So I'm going to start with our lecture. I'm going to share once again the note for today. For your information, the note for today is also available on ITEL. Yeah, it's also available on ITEL. And also, the note for today is also shared with you through the WhatsApp group. Okay. So today's lecture is lecture 14. Supposedly this lecture is our last lecture. Okay. This lecture is our last lecture. And just for your information, after our last lecture, we are going to have another test, which is sometime next week, if I'm not mistaken. Yeah. All right. So in the last two lectures, settlement and consolidation, we have covered the settlement on clay. Particularly, we have covered the settlement on immediate settlement, and also we have covered the settlement on primary consolidation settlement. All the yellow part we already covered. Yeah. We also talk a little bit about normally consolidated clay and over consolidated clay. These are the part that we covered in lecture in part 1 and also part 2 of consolidation and settlement. So today we are going to continue on, but today we will discuss or look more into the calculations of the settlement when time factor is taken into consideration. Yeah, when time factor is taken into consideration. Now, in lecture 2, can you guys see the knots moving? Can you see the knots moving? Can you see the knot moving? Okay. All right. Nota boleh nampakkan? Slide boleh nampakkan? Boleh ya? Okay. So if you look into lecture 2, if we look into lecture 2, we focus on how you can calculate SC, which is the total settlement. Total settlement, if we know the layer profile of the site, and if we know the FCL graph, FCL, which is the field consolidation line. Yeah. So equation SC here is the most common equation that we can use to calculate the total settlement. Now, beside this main equation, we also have several equations that we can use as alternative. Yeah, we can use as alternative. What are the alternative equation? Okay, the alternative equation. The alternative equation for normally consolidation style given here. Okay, SC equivalent to CC, height of the soil or height of the thickness of the clay soil divided by 1 plus E naught and multiply with log current pressure over the previous effective overburden pressure, where CC in this case is the slope of the FCL. So you look into your void ratio against pressure log scale graph, and you can find the slope of the consolidated soil. The slope is CC or coefficients of compression. So you can use that as an alternative formula. Yeah. Similarly, if you look into the rebound line, yeah, if you look into the rebound line here, you can see that the slope of the rebound line is equivalent to the recompression index or CR. Recompression index or CR. So, which is actually equivalent to the slope, yeah? So if we want to use the CR as alternative formula, we can use the equation alternative number 2, yeah? Where CC is replaced by CR. This is more commonly used for over-consolidated clay. Therefore, we can see that there are several alternatives for SC. Either you use CC for normally consolidated, or CR for over-consolidated, or we can use both CR and CC for over-consolidated soil where the current overburden pressure is larger than the effective overburden pressure. Okay, these are some of the alternative formula for total settlement SC. All right, now let's look into one example. Okay, let's look into one example, which is alternative way to calculate the effective, the total settlement. Yeah, so in this example, we look into foundation, the soil profile on the left side. Okay, the soil profile on the left side. So if you look into the soil profile on the left side, you can see that there are several layers. You have clay, sand, and gravel. And also you have, what you call it, foundation constructed at depth 4.5 meter below the ground. 4.5 meter below the ground. Okay. So in this question, it asks you, what is the SC value? Using the alternative. Using the alternative CC, if we know all of the other parameters. So, solving this problem requires you to find the CC. Luckily in this case, the slope of the FCL, here is given in the question. So you look here, the slope of the compression index is given 0.68. Yeah, 0.68, meaning that you now have the compression index CC in the equation 0.68. You now have the thickness, which is the thickness of the clay. You only need to calculate the current effective pressures. Yeah, current effective pressures. So the step is similar. Yeah, plot the FCL. In this case, FCL is not needed. Yeah, calculate effective overburden pressure, current pressure. So this is our current pressure. Check if any deduction needed. Yeah, if deduction needed, then calculate the additional stress. Additional stress using the influence chart. Then after you calculate the effective overburden pressure and the stress increment, you can calculate the current effective pressures by total up the effective overburden pressure and also the stress increment, and then you can use that to find void ratio from the FCL. But in this case, the void ratio is given. So if you look into the question here, the void ratio is given. Yeah, compression index is given. Okay, so initial void ratio is 1.38. Compression index is 0.68. So what you need to do? Okay, follow the step-by-step guideline. Follow the step-by-step guideline. Yeah, you follow the step-by-step guideline. Plot the FCL, not needed. Calculate effective overburden pressure P naught. Okay, so you calculate the P naught here. Yeah, unit weight multiply with the thickness. Unit weight multiply with the thickness. If there is a groundwater table, then you minus with the groundwater table. So you obtain effective overburden pressure as 123.1. Okay, 123.1. This is the effective overburden pressures calculated from the top of the soil layer to the middle of the clay layer. Yeah, all right. Then what is the next step? The next step is deduct the excavation. Consider the excavation. Yeah, the excavation is what? Excavation is look into the structure. Look into the structure here. So if you look into the structure, you dig 2 meters. 2 meters of the first layer, and then 2.5 meters of the next layer. 2.5 meter of the next layer, and 2 meter of the first layer. Therefore, your excavation here, 2 meter of the first layer, plus 2.5 meter of the second layer. Yeah, of the second layer. Therefore, the unit weight or the weight of the pressure of the excavated soil when you are digging for the structure is 64.7. 60.7. 64.7. Meaning that the loading supported by the structure, is load divided by area minus the excavation, which is 64.7, which the total of 235.3 kilonewton per meter square. See, initially, you have the net pressure load divided by area. Because there are some excavation, you minus the excavation to obtain the net pressures. Okay, so this is step number 2. Okay, now next, what is our step? Okay, what is our next step? Our next step is calculate the stress increment. Okay, our next step is calculate the stress increment using the influence chart. So again, the foundation is in square. The shape of the foundation is in square. Oh, so this is in square. So you divide that into 4 mini square. Why we divide into 4 mini square? Because we want to determine the stress at the center. At the center. Why at the center? Because the center is where the focus of the load is increasing. Yeah. Oh. The focus is increasing at the center. So we calculate one by one of the 4 square. What is the stress at IBXH? What is the stress at BC, DX, XDEF, XFGH? And we total up the stress at this point as your additional stress. Yeah, as your additional stress. Okay. Remember, whenever we are calculating the total stress and using the influence chart, make sure the value of the Z, which is the distance from the base of the foundation to the middle of the clay, is accurately calculated or measured. In this case, 6.7, yeah? So remember, what is Z? Z is the value from the base of the structure here, 3.6, until middle of the clay, layer. Therefore, in this case, Z is 6.7 meter. Yeah, Z is 6.7 meter. All right, Z is 6.7 meter. Okay. Now, after we split into 4 equivalent area, we calculate stress by stress using the table. Okay, because the 4 squares are equivalent size. I only calculate once. Yeah, and because it is square, I calculate the value of m, which is length divided by the depth z, and n, which is the breadth divided by the length z. So 0.45 and 0.22. I use the influence chart to determine the influence factor. I obtain 0.04. Therefore, stress increment due to the one square is 235.3. Dari mana datangnya 235? This one comes from here, 2335, the net pressure. Yeah, the net pressure. So the net pressure is 235.3 times the influence factor for square number 1, which is 9.4. For square number 2, same, 9.4. Square number 3, same, 9.4. Square number 4, same, 9.4. So the total is 37.6 stress increment. So initially, the stress is 1 to 3. After the construction, increasing 37. So therefore, okay, therefore initially P naught is 1 to 3. After the loading, P ataupun stress adalah 1 to 3 plus 37.6 stress increment. So the total is 160.7. Therefore, knowing the void ratio 1.38, knowing the thickness of the clay 6.4, knowing the coefficient of compression, which is 0.68, we can calculate the total settlement. We can calculate the total settlement using the alternative formula. Using the alternative formula. Okay, so we insert all of the known parameters. We use all of the known parameters. Then we can find that the total settlement is 0.212 meter. Okay, 0.212 meter. So now this figure, we can predict that the settlement is 0.212 meter, particularly at the clay layer. Because we study consolidation and settlement of the clay layer. So the structure, your foundation will settle for 0.212 meter. So meanings that what? Meanings that there is an alternative formula for SC. Commonly, we use the one at the bottom here. Okay? But through this example, we learned that CC, the slope of the consolidation, can also be used to calculate the total settlement. This is the alternative formula. Okay? This is the alternative formula. All right? Okay. Any questions so far? Any questions so far? Kalau tiada question, I'll continue. All right. So now in summary, we can see that the study on settlement and consolidation expose us to the relationship between volume, mass, and the volume of soil. What happened to the layer of clay when the load is applied? Yeah, of course, there is the consolidation and settlement. And of course, through this equation, we learn how to predict, how to calculate the total settlement. Okay. Other parameters can also be derived, such as the coefficient of volume compressibility and also coefficients of compressibility. Okay. Coefficients of volume compressibility and coefficients of compressibility. These are some of the other relations between the soil weight and the soil volume. Yeah. Now, let's go to same topic, but more to the time factor. Yeah, time factor. All right. So, based on what we learned so far, in part 1 of consolidation and settlement, and in part 2, we know now how to calculate total settlement. Yeah. So if you look into soil profile, yeah, soil profile here, before settlement, the thickness of the clay is H meter. Before construction or before settlement. After the construction, soil will settle. Yeah, there is a reductions of thickness, which what we call the settlement, equivalent to amount of SC. Therefore, based on what we learned so far, we know how to calculate the total settlement. Yeah, we know how to calculate the total settlement, and we know also how to calculate the time it takes for the settlement. For example, 3.5 years. Total settlement, for example, 7.5 centimeter, and so on. Okay, this is the total settlement. But what are the things that we do not know so far? Okay, what are the things that we do not know so far? What we don't know is the amount of settlement at any given time. Yeah, We only know the total settlement at the end of the settlement process. We do not know the settlement at any given time. Yeah. Also, how long it takes for a centimeter to settle, we do not know. Yeah. Therefore, to solve this issue of the things that we do not know, we introduce time factor or TV. Time factor or TV. Yeah. Time factor or TV. TV is a constant that we use to study the amount of settlement over a given time and the amount of time over a given amount of settlement. Yeah. So we call it time factor. Symbol given is TV. Okay. TV. Now, what is TV? What is time factor? What is time factor? TV is a coefficient depending on percentage of consolidation. For example, if uh, if you are given a settlement of 10 centimeter, the question will ask you, what will be the settlement at time equivalent to 1 year? Or what will be the time it takes for settlement of half of the SC? This is where time factor is introduced, because time factor gives you the relationship. Time factor gives you the relationship TV ni, yeah, relationship between time, between the thickness, and between the coefficient of consolidation. Yeah. So time factor ni linking the time, the height of the clay, and also the coefficient of consolidation. Therefore, if we have time factor, we can solve the question here. The thing that we do not know. Yeah? The things that we do know, we can solve using time factor. All right. Any questions so far? You can type your question. If you have any, you can type your questions. I will read it out. Yeah? All right. Now, the study where time factor is intertwined with total expected primary consolidation SC is the study related to the rate of settlement. Rate of settlement. Sebab kita, we link the time with the consolidation amount. So, means that we are actually studying the rate of the settlement using this rate of settlement equation. Yeah. So, if given time factor, we can calculate time. If we given time, we can calculate coefficient of, we can calculate the amount of settlement. So this is the equation. So you look into fraction of the primary consolidation U here. U ini refers to the percentage, yeah, refers to the percentage of settlement. Meaning that if the total settlement is 1 meter, if the settlement is 0.5 meter, maksudnya U equivalent to 50, half of the settlement. This is what you call fraction of the total primary consolidation. Yeah, total of the primary consolidation. Now, time factor is constant. In exam, time factor is usually given. Yeah. In exam, the value of the time factor is given. For example, at U 50%, maksudnya when the settlement is complete 50%, what is the time factor? The time factor is 0.196. How do we get the 0.196 time factor? The time factor is calculated or obtained from the chart here, time factor chart, we look into 50%. Time factor is 0.169. 196, sorry. You look into time factor of 90%. Time factor is 0.848. Therefore, the equation of time factor will change, the constant of time factor change based on the percentage, okay? Based on the percentage. Beside the table, here, time factor can be obtained from the table. Beside this table, we can also obtain time factor from this chart, this figure. Yeah, if we know the percentage of consolidation, let's say 50%, we scale off from the 50%, you get the time factor 0.2. Or you have 70%, you scale off, you get the time factor 0.4. So this is the alternative. If you are not given this table here to calculate time factor, you can also use this chart. Yeah, you can also use this chart to calculate time factor. Alternatively, also you can use the equation on the right side. Yeah, time factor on the top here, pi over 4 divided by u over 100 square. This one is for u less than 60%. Meanwhile, the time factor can also be used equation for larger than 60. Is equation 1.781 minus 0.933 log 100 minus u. These are some of the alternative to calculate time factor. Yeah, you can use the figure, or you can use the table, or you can use the equation. Yeah, to time factor. What is the importance of time factor? Or more importantly, how do you use time factor in equation, in solving equation? How do you use time factor in solving equation? Let's look into this example. Okay, let's look into this example. All right, so look into the example. Please pay attention, everyone. Probably this mungkin masuk exam nih. The total consolidation settlement for foundation is 7.5 cm. We know the layer of clay will settle 7.5 cm based on previous calculation. Okay, 7.5 cm based on previous calculation. This is the SC value. Okay. Lab consolidation test found that the coefficient of consolidation is 0.0212. This is from your either Taylor or Casagrande. 0.0212 cm square per min. Okay. Calculate how long it takes for 20% of the settlement, meaning that 10, 20, 30, 40 until 90% of the settlement to happen. 10% of the 7.5 cm, 20% of the 7.5 cm, and 30% of the 7.5 cm, and so on. If the clay layer is double drainage, and if the clay layer is single drainage, look into these two cases. Double drainage and single drainage. What is the difference? Double drainage means that the clay layer here, the clay layer is located between two permeable soil. In this case one, you look into the 4-meter clay. The 4-meter clay is located between sand, which is permeable, and gravel, which is permeable. So if the layer of clay is consolidated, the water will flow out. Remember, consolidation means water flow out. So when the construction happens, the water from the clay will flow out to travel. To travel means that Either it flow out to the top because sand is permeable, or it flow out to the bottom because gravel is permeable. Therefore, the distance for the water to travel out from clay to sand and from clay to gravel is equivalent to thickness H divided by 2 because it can flow both ways. During consolidation, water from clay can flow out through the bottom or the top side. Therefore, the distance for the water can travel is H divided by 2. H divided by 2. In opposite, you look into the drainage, single drainage on the right side. You look into single drainage on the right side. You can see that this is for clay soil. Yeah, this is for clay soil where the top layer is sand. The bottom layer is impermeable bedrock. So when construction is happening at the single layer, single drainage, the water from the clay also will flow out, but it will flow out only from one direction, which is to the sand, because sand is impermeable, sand is permeable. It cannot flow out into the impermeable bedrock. Therefore, in this case, H is equivalent to 4 meter. Beza dia dengan double drainage. For double drainage, H is half of the thickness. Why this is important? Because you look into the equation. You look into the equation here. We look into the equation here. If we are solving single drainage, H here equivalent to the thickness of the clay because water flow out only one direction. If the soil profile is permeable top and bottom, in this equation, H will become H divided by 2 because water can flow out on the top and on the bottom layer. Yeah. Therefore, in order for us to solve case 1 and case 2, let's separate into 2 solutions. Let's separate them into 2 solutions. This is solution number 1. Solution number 1, double drainage. Yeah, solution number 1, double drainage. So the question asks you to check what is the settlement at 10% and how long it takes the time. Yeah, 10, 20, 30 until 100. Solve this using the equation. So very easy. Okay, very easy. TV we can find from the chart. SC we can multiply from the percentage. Meanwhile, from the time we can use the time factor equation. Yeah, this is for case 1, double drainage. For case 2, also same, but in this case, we look into the H. H different. For single drainage, the drainage H is still maintained as 4 meter because water flowing one directions only. Yeah, one directions only. Right. So the solution for case 1 such as follow. Yeah, such as follow. Because it is double drainage, the height H is 200 centimeter. Oh, sorry, 200 centimeter or 2 meter or 200 centimeter. Therefore, given U100, we can find the time factor TV. How do we find this? From chart, from table, from equation 0.0077. Then 10%. What is the settlement at 10? You 10% or times the given total lah. 10% times 7.5. Dapatlah 7.75. 0.75. Yeah. How about time? How about time at 10? So when we look into time, you go back to the equation. Go back to the equation. Okay. Time factor we know. Time factor we know 0.077. H we know 200 cm. CV we know given 0.0212. Remember, the CV value is given in centimeter. Therefore, your H pun centimeter. Okay? Solving the equation, we find the time at 10 equivalent to 0.027 year. Meanings that the footing will settle approximately about 0.75 centimeter in 0.027 year. This is 10%. If you repeat the calculation for 20%, if you repeat the calculation for 20%, you can see that the time factor is 0.0314 from the equation, yeah, or from the table, or from the figure. And then SC adalah 20% of the total, so 1.5. And time 20, again, we go back to the equation. Yeah, we go back to the equation. We can solve that T20 is 0.113 year. Okay, meaning that the footing will settle approximately 1.5 cm in 0.113 year or 41 days. This is for double drainage. Yang membezakan, that differentiate double drainage and single drainage is the value of the hedge. Yeah, the value of the hedge. So you see the single drainage. Okay. Single drainage. You look into the value of the hedge. 400 centimeter. You know why it is 400 centimeter? Okay. Anyone know why single drainage is 400 centimeter? Why for single drainage, hedge is 4 mm and double drainage, hedge is 200 cm. Anyone know? Can anyone answer this question? Okay. Why? Kenapa ada dua H yang berbeza? Okay. Anyone? Can anyone guess? Why single drainage? Kita guna H 400 cm. Why double drainage? We use H 200 cm. Why? See this one 400 for single drainage. For double drainage, we use 200. Anyone? Can anyone guess? Anybody want to try?
Because one way and two way.
One way and two way. Okay. One way and two ways. Correct. Okay. Because we look into the movement of the water. If it moves one way, so we take the H value unchanged. if it move both ways, we divide it into 2. Okay, correct. Okay, so therefore, you have the answer for single drainage and double drainage. Yeah. Now, this is another comparison side by side. Okay, comparison side by side. Single drainage 400, double drainage 200. Yeah, same calculation. I just put it in this table because I want to see side by side. Yeah, side by side. Yeah, and if we look the solution, if we compare the solution, the answer, we can see the time rate of settlement is faster in double drainage. Meaning that if the layer of the soil consists of double drainage, 2 ways out, the building will settle faster. Faster because the water has a chance to move out faster because it can move up bottom or the top side. Meanwhile, on the single drainage, you can look here, it will take slightly longer time. 90%, for example, look into 90%. 90% consolidation will take 3 years for double drainage, but for single drainage, it takes 12 years. So, conclusionnya adalah rate of settlement is faster in double drainage condition. Similarly, if we plot, we can see here the drainage, single drainage and double drainage. Double drainage, the rate is faster than single drainage. So in comparison purposes, yeah, this is for comparison purposes. So now we can learn that beside the total settlement and beside the what you call it, the soil profile, we can also study the rate of the settlement. Okay. So another example here. Another example. Okay, look into the look into the diagram. Look at the diagram. Look at the diagram. There is a clay layer, right? Clay layer. The thickness is 3 meter. Okay, the thickness is 3 meter. The top side is permeable. The bottom side is impermeable. So the water can flow only one way. So H, kita pakai 3 meters. Bukan 3 bahagi 2. Kita pakai 3 meters, ya. So given that the total settlement is 6 centimeter and the coefficient of consolidation is 0.0172 cm square per minute. Cm square per minute. Therefore, the question asked here. Question asked here. How many years? How many years for 90% of the 6 centimeter to happen? Berapa tahun? How long it takes for 90% of the 6 cm to happen? Question number 1. And question number 2, what is the settlement at t equivalent to 1 year? And question number 3, find t for settlement 2.5 centimeter. See, these questions are all about rate of settlement. You know the time, you want to know the settlement. You want to know the settlement, you want to know the time. Therefore, if you want to understand or learn the easiest way, I give you tips. Tips ini, if you know these tips, you can understand our lecture today. The tip is given in the chain equation here. SC U TV T. Meaning that Meaning that if you are given SC and you have to find time, what you can do is you use SC to find U, then use U to find time factor TV, and use time factor TV to find time in that direction. Similarly, if we are given time T, if you're given time T and you want to find amount of settlement, so you use time to find TV, time factor to find fraction of consolidation, U, and using fraction of consolidation to find amount of settlement. That is the tips. This is the tips. Okay? This is the important tips. All right. Meaning that, let me repeat again. If you are given U, you have to find time. What you can do is use U to find time factor and use time factor to find time in that direction. Yeah, in that direction. Similarly, if you are given time, but the question asks you to find settlement, what you can do? You use time to find time factor dulu, and then you use time factor to calculate U, which is the fraction of the equation, and then you use U to find SC in that direction. Yeah, so easy. If you know this method, you can solve any problem related to rate of settlement. Okay, so if you are given time factor, you are asked to find SC, very easy. Use time factor to find U, fraction. Use U to find SC. Itu cara dia. If you know this, you are not going to be confused. Yeah, you're not going to be confused. Let's try one example. Let's try one example. Okay, let's try one example. How many years? How many years it takes for you 90% to happen? So apa yang kita ada? You are given U 90%. You have to find T time. So what you can do? If you are given U, find time factor TV using the table, then use TV to find T using the equation. Contohnya answer here. If U is 90%, from the table, look at the table on the right side. From the table, time factor is 0.484. Therefore, using the equation, I have the time factor, I have H, and I have the CV. I can calculate the T90, which is 8.40 years. So we know the direction. We must know the direction. You just follow the hint here. So kalau kamu susah untuk paham, you always focus on this. Yeah. Now next, what is settlement in 1 year? Meaning that what? You want to find SC. You want to find SC, but you are given time. What is settlement SC? In 1 year, T equivalent to 1. So what you can do? Meaning that here, you are given T, time. So if you follow the hint or the tip study, if you know the time, you can find time factor from the equation. If you know the time factor, you can find the U from the table. If we know U, you can darab to get amount of settlement. Therefore, in this case, 1 year, 1 year, 1 year. So we know time factor 0.10. Okay. From the time 1 year, we know the time factor 0.10. Okay. Therefore, okay, 0.10. So therefore, it give you the value of the U 35%. The final answer is 35% from the SC, which is 2.10 centimeter. Okay, 2.10 centimeter. Okay, 2.10 centimeter. Okay, similarly, yeah, similarly, if we are given settlement 2.5, what is the time? Again, you follow the hint. Settlement, find U dulu. So dalam U ini adalah 2.5 cm divided by 6, which is 40%. After find U, find TV. From the graph, U 40% is 0.126. After TV, find T. So T adalah 1.25 years. So you follow the direction to solve the rate of the settlement using this. Most importantly, using this. Ini akan masuk dalam exam. Okay? Ini akan masuk dalam exam. Alright. So we are halfway. Kita slide nomor 31. I would like to take a short break dulu. Okay, so I will take a short break. We will be back in 10 minutes. we are back on our topic. Tapi sebelum itu saya mau bagi sedikit. I want to give a few tips regarding the next test 2. For your information, this is our last lecture. And we finished our lecture right on time. Very good time management, because we never take any cuti, and also we never miss any tutorial as well. Therefore, we managed to finish our lecture on time. Yeah. According to our schedule, you will have your test 2 next week. So I want to give tips regarding test 2 next week. So I want you to pay attention to the tips. So test 2. Tips for test 2. So there will be 2 questions. There will be 2 questions. One question is question 1. This one is returning structure design. Question 1 is returning structure design. And question 2 is settlement and consolidation. Okay, so this one is a long question. All right. So question 1 is returning structure design. This one is pretty standard. So in question 1, you are given a structure. You are given a structure, and you have to determine the factor of safety for overturning, sliding, and bearing capacity, and so on. So it's pretty standard. Yeah. For question number 2, settlement and consolidation, you are looking into 3 parts. One is regarding graph for CV, coefficients of consolidation. The second part is regarding calculations of total settlement. Yeah, FCL lah, FCL dengan total settlement. And the third part is rate of settlement. What we just learned today. Yeah. So you need to study all 3 settlement and consolidation. You have to make sure that you bring graph papers and also the stress increment. I will give the influence chart. Okay. So I will give more tips in the future, but this is the tips that I'm giving for question number 2 or test number 2. Another assessment is the PBL poster presentation. PBL poster presentation. In PBL poster presentation, the presentation is conducted online. And you have to prepare one poster, PDF poster, A4, and then your group need to present it to me online, and you use the PDF to summarize the 3 objectives in your PBL report. Meaning that the poster is actually a summary of the PBL report. Yeah. So create a poster, PDF poster, upload on Schoology, on ITEL. Then next week, your group will be given a timetable where you can present your findings to me as a group. So you have about 10 minutes, 10 to 15 minutes to present your poster, your PBL poster. Okay? All right. Am I clear? Do you have any question? Any question? Tiada question? No question?
Iya, dokter.
Okay. If there is no question, I will continue our lecture for today. All right. So, next part is I want to cover more on the secondary compression settlement, the thing that I circle here. Yeah, because we already finished the yellow part. So now we look into secondary compression settlement. If you remember, during the first part of the consolidation and settlement, I mentioned that there are three types of settlement. One is immediate, one is primary consolidation, one is secondary compression. Secondary compression is the last part. Immediate settlement is when the air is removed out of the soil layer. Consolidation primary is when the water is removed out of the soil layer. Meanwhile, secondary compression is when the grain particle size is rearranged. And the rearrangement of the particle size reduce the thickness of the layer slightly. And this one will take a long time. Therefore, almost close to infinity. Yeah, almost close to infinity. Therefore, we usually mention how long you are going to study the secondary compression. Yeah. So, is secondary compression. So if you look into figure here on the right side, you can see that once the primary consolidation is complete, at point A, the primary consolidation is complete. After primary consolidation complete, we continue on with secondary compression. Yeah. So the thickness of the secondary compression is settlement SS. Yeah. Secondary settlement is, the formula is SS. Now, in order for us to calculate the secondary settlement, we have a coefficient called coefficient of secondary compression, which is C alpha. Yeah, C alpha. At the same time, because of the duration is almost close to infinity, when we study the secondary compression, we estimate or fix the point of question. Yeah, so in this question, we start from TS and we finish the study at TP, or TP we study at TS, for example, because we do not know how long the process will be. Yeah, and the coefficient of consolidation, C alpha, is obtained from figure 7.22. Figure 7.22. This summarizes the coefficients of secondary compression based on the natural water content of the soil. That is why in your PBL, I asked you, what is the natural water content of your soil? What is the natural water content of your soil? Because if you know the natural water content of your soil, you can scale off either using the undisturbed sample line or the recompression line. You can scale off from Paxi X, and then you can obtain the C alpha, the secondary compression coefficient, on y-axis. So important for soil to obtain the natural water content if we want to study the secondary compression. Yeah. So here, important to know the natural water content because it signifies the coefficient of secondary compression. Okay. Let's look into this example. Okay, let's look into this example. So in this example, a foundation is to be built on sand deposit underlain by compressible clay 5-meter thick. The natural water content is 80%. Primary consolidation stop in 10 years. What is the secondary compression after between 10 to 50 years? Between 10 to 50 years. So in this question, we know the thickness is 50. The water content is 80. And the primary consolidation stop, meaning that TP lah. TP is 10 year. And the secondary compression, the one that we calculated is 50 years. So TS adalah 50. So we can have the question here. What is H? What is TS? And what is TP? What we do not know is the coefficient of the secondary compression. But remember, we are given the water content. Therefore, from the graph here, water content 80%, the coefficient is 0.015. Yeah, from the graph. Water content 80%, the coefficient of secondary compression is 0.015. Therefore, from year 10 until year 50, the secondary compression SS is 0.051. So this is pretty easy. It's quite straightforward. You use the equation, and in the equation, the most important part is the coefficients of secondary compression, which is obtained from the natural water content. Yeah? Okay. Any question? Any question? Any question? Okay. If there is no question, I explain the last part. Okay, the last part is settlement on sand. Settlement on sand. When we study the settlement on sand, it is important for us to know the SPT value. SPT and value. SPT and value. What is SPT and value? SPT is standard penetration test. Standard penetration test. Standard penetration test is using this equipment, this one. Yeah. This is SPT. SPT maksudnya, we use the penetration test. We hammer the wet into the ground. We calculate how many times you hammer the ground, the wet into the ground for it to pass the layer of the soil. N, we call it N value. So dia ketuk. You calculate how many times for every meter of the soil layer. Yeah, that is what we call the N value. Yeah. Therefore, after we have the N value, we also need to know the ratio between the length and the breadth. When you're designing your structure, you have the length and the width. The width is the breadth lah. So you calculate the rate, we call it the rate of the length and the breadth. Yeah, so these two are the parameters needed for design or for calculation of the settlement in sand. Yeah. Now, once you have these two parameters, one is the SPT value, two is the ratio between length and breadth, then you can analyze the settlement on sand using two principles. One is you calculate the settlement based on the allowable pressure. Two is you use the standard settlement to limit the loading Q in design. These are the two approach when it comes to settlement on land. Samada, we calculate the settlement, or we use one value of settlement, let's say 16 millimeter, then we use the 16 millimeter maximum to obtain what is the maximum limit for loading. These are two approach for settlement on land. Ya, two approach. Satu, kita calculate the settlement by the given loading. Two, we fix the settlement and we can calculate the allowable limit loading. Yeah. So these two methods, let's look into the difference. Yeah. If we want to calculate the settlement, see here, this first equation is the equation we use to calculate the settlement based on allowable loading. So if you look into the equation, you can see that S is the settlement. This is the one that we're calculating. S. B is the width of the footing, lebar footing. And prime. This is the SPT value. Based on the site investigation test, they're hammering the layer of soil. We have the SPT value. This is the value that we use in this equation. Yeah. Q is the contact pressure. What is the load of the design? What is the load divided by the area of the design? This is Q. Meanwhile, P naught is the in situ effective overburden pressure at the base of the foundation. Bukan at the middle of the clay layer. If we study the clay layer, P naught is measured from the ground to the middle of the clay layer. But if we study the settlement of the layer of sand, P naught is from the ground to the base of the footing. Therefore, if we use this equation, we can calculate the total settlement S based on the pressures of the foundation that we are designing. Yeah. Meanwhile, we can also use these two equations to give a range of the allowable design. So in this case, equation 7.27 and 7.28, yeah. One is for the square, one is for the non-square, yeah. L and B, one is square, one is the non-square, yeah. In this equation, 7.27 and 7.28, we use it to limit the loading design by fixing the settlement as either 16 millimeter or 20 millimeter. This one is the standard lah. Okay, so kita katakan the limit is 20. If using the limit 16 millimeter, this is the allowable design. So there are two ways of approaching. Yeah, one is calculating the settlement based on the loading. Two, giving the range of the loading based on the standard settlement. Yeah, so two way of approaching. So, okay. Another thing, before I give you a last example, another thing is that the SPT value also need to be modified. Yeah, especially if the soil is dense or silty sand. This is the formula to modify the N value. To modify the N value. The reason why it's modified because you want to standardize. You want to standardize the effect of the loading weight to the type of the soil. Yeah, want to standardize the effect of the hammers wet to the type of the soil. Okay, so we standardize first. If only for the dense soil and only for the silty sand. Yeah, only for the dense soil and only for the sand. Okay. Last example. Okay. Now, now in this example, you have a foundation with depth 1.5 meter. Foundation depth 1.5 meter. The size is 3.3 footing. Constructed on sand. Unit weight 18.3. SPT value 30. Okay. Calculate the allowable pressure Q for settlement of 25. So if we are using factor of safety 1.6, factor of 5 is settlement is 25 divided by 1.6, 16. Okay. Therefore, in order for us to find the solution, what we can do is first, using the equation, find P naught value. P naught value is the depth effective overburden pressure from the top to the bottom, which is 27.45. Okay, 1.5 times 18.3, 1.5 darab 18.3, you got 27.45. Then, using P naught 27.5, insert into the equation, we find the allowable 501. So in this case, we use the settlement to define the range of allowable loading. Okay, define allowable loading. Another method is using this equation. Another method is using this equation. In this case, you look into the figure. X-axis is the width of the footing, and y-axis is the value of the Q. If we know the width of the footing, we scale off to the value of the SPT, and then we obtain the value of the Q, and we use the Q to find Q, to find the value of the allowable design. Yeah, so obtain the value of the Q to find the allowable design. So in this case, if we use the same question, we can see that the value of the Q is 30. Therefore, the allowable design is 498. So in this case, if you look into the difference between the answer, here the answer is 501. But if you're using the second method, the answer is 498. So there is two different methods with almost similar answer. Both can be used to determine settlement in sand. So in settlement in sand, usually we are limiting the settlement. We are using the value 16 to control the value of the loading Q. Yeah, the value of the loading Q. All right. So that is the final of our topic today. So in conclusion, yeah, in conclusion, Today, we have covered the study of the settlement. On clay, we have covered the settlement on immediate settlement, primary consolidation, and secondary compression. Okay, and secondary compression. And then you can see also the secondary compression for settlement on sand based on SPT value and also the ratio value. Okay. All right. So that is the end of today's lecture. We still have one tutorial. Our tutorial is supposed to be this Thursday, but this Thursday is public holiday. Therefore, we can plan to move the tutorial to probably Friday. If it is okay with you, only 1 hour. You can discuss and confirm with me later what time you can change the day of the tutorial classes from Thursday to Friday. So your class rep monitor can confirm with me later on, right? Okay, so that is all for today. Any question? Okay, if there is no question, I have the attendance here. Okay, please sign for your attendance. And see you guys again this Friday, 1 hour for tutorial. Okay, probably in the morning this Friday. All right, thank you very much. See you guys again this Friday.
Thank you, Doctor.
Thank you, Doctor.
Thank you, Doctor.
Thank you, Doctor.
Doctor. Thank you, Doctor.
Thank you, Doctor.
Thank you, Doctor.